Determine the left-sided limit and the right-sided limit, and the two-sided limit as x approaches 3 of 3x minus 12 divided by x cubed minus 7x squared plus 12x. Each of these involves the limit as x approaches 3 of 3x minus 12 divided by x cubed minus 7x squared plus 12x. The first thing to do is try plugging a 3 in for each of the x's. That will give 3 times 3 minus a 12 divided by 3 cubed minus 7 times 3 squared plus 12 times 3. 3 times 3 is a 9 minus 12 divided by 3 cubed is a 27 minus 7 times 3 squared, which is a 9, plus 12 times a 3, which is a 36. 9 minus 12 is a negative 3 divided by 27 minus 7 times 9 is a minus 63 plus 36. This gives a negative 3 divided by 27 minus 63 is a negative 36 plus 36, which is a 0. The 0 in the denominator is not actually a 0 since x is only approaching 3, it never reaches 3. But a limit result of a non-zero number divided by 0 is a positive infinity or a negative infinity, and the sign of the infinity often depends on the side the limit approaches from, so it will be necessary to work out each of the one-sided limits separately. We have the left-sided limit indicated by a negative superscript on the 3 of the 3x minus 12 divided by x cubed minus 7x squared plus 12x. And the right-sided limit indicated by a positive superscript on the 3 of 3x minus 12 divided by x cubed minus 7x squared plus 12x. Let's start with the left-sided limit. The first thing to do is to factor the denominator so that we can see the factor that is making 0 in the denominator. The denominator is a cubic, but since it's missing its constant term, it has an x in every term, and a common factor of x can factor out, leaving behind x squared minus 7x plus 12. Which is a trinomial quadratic and can further factor. The numerator can be left alone, and the denominator will factor into an x, two numbers that multiply to be a positive 12 and add to be a negative 7. Negative 3 and negative 4 will take care of that. X is approaching 3 here, and therefore the x minus 3 factor will be the one that's making 0 in the denominator. It's approaching 3 from the left side. The left side of 3 is less positive than 3, like 2.99. And if that were plugged in for x in the x minus 3 factor, 2.99 minus 3 will be a negative number. It will be approaching a 3, therefore the x minus 3 will approach to a 0, but it'll be a negative number, so we can replace x minus 3 with the negative 0. All other x's can be replaced with a 3. That will give a 3 times a 3 minus a 12 divided by a 3 times a negative 0 times a 3 minus 4. 3 times 3 is a 9 minus 12 over a 3 times a negative 0 is a negative 0. Negative times positive gives a negative. And then a 3 minus 4 is a negative 1. 9 minus 12 is a negative 3, divided by a negative times a negative is a positive. 0 times 1 is a 0. We have a negative divided by a positive, which is a negative, and a non-zero divided by a 0, which is an infinity. The left-sided limit will be negative infinity. The right-sided limit will work out in a similar fashion. Factor out the common factor of x in the denominator, leaving behind x squared minus 7x plus 12, which itself will be able to trinomial factor exactly like the left-sided limit into an x minus 3 and an x minus 4. This is the right-sided limit of 3, which is more positive than 3, like 3.01. If that were plugged in for the x in the factor that's making 0, 3.01 minus 3 will be a positive number. But x approaching 3, so x minus 0 approaches 0, so it will be a positive 0 that we can replace x minus 3 with. And a 3 can be plugged in for all remaining x's. That will give a 3 times a 3 minus 12 divided by a 3 times a positive 0 times a 3 minus 4. 3 times 3 is a 9 minus 12 divided by a 3 times a positive 0 is a positive 0. 3 minus 4 will be a negative 1. 9 minus 12 is a negative 3 divided by a positive times a negative is a negative. 0 times 1 is a 0. A negative divided by a negative is a positive, and a non-zero divided by a 0 is an infinity. Now, the result of the right-sided limit will be positive infinity. The two-sided limit depends on the results of the two one-sided limits. They do not match each other here, negative infinity and positive infinity, and therefore the result of the two-sided limit up here will be does not exist, and there is the results of the three different limits.